Hello everyone, welcome to day 14th of Talanta 50-day consecutive NEET 2023 special crash course series. Today we are going to discuss 13 MCQ, very important type of MCQs of alcohol, phenol and ether. Let's begin with this first problem. In a given reaction, the product P is, so this 1,2-diol cyclic diol is present, that is being treated with a ketone acetone and in presence of dry HCl. So what we have to understand is the 1,2-diol. This is basically, if you have gone through it in a proper way, you will see this is basically a locking reagent. 1,2-diol acts as a locking reagent from aldehyde for aldehyde and ketone. So basically what will happen over here is these 2H and this one O is will be dehydrated as minus H2O, and the cyclic ketal will be formed. So this will be the product, this one. Option B is the correct answer. And if it is further treated with H3O plus, it will give back this one. This is very important as well. So sometimes it is asked in the competitive exam, this locking reagent, this locking stuff, cyclic ketal or cyclic acetate is being treated with H3O plus, then what will be the product? You know, always remember, you just leave the bond in this way. You put H here, you put H here, and put a double bond O over here. So that H2O will be introduced in that fashion, and we'll get back the ketone or the aldehyde and the 1,2-diol as well. So moving to question 2. In the given reaction, product P is, this alkene is given, it is being treated with mercuric acetate in presence of methanol, and water is there, and then NaBH4. Well, this is a very straightforward naive reaction. It's oxymercuration, demercuration. Here, hydration of alkene happens by following Markovnikov's rule, and the most important thing is that in these Markovnikov hydration reaction, no rearrangement occurs, because here the intermediate stuff does not go through carbocation formation. So straightway Markovnikov addition of H2O. So these contain one hydrogen, these contain no hydrogen. So the carbon containing lesser number of hydrogen will take the anion part from water. So OH will be inserted here and H will be inserted here to get CH2. So option C is the correct answer. Well, third question. The best method for synthesis of given ether by Williamson's ether synthesis is. So this is the given ether, and we have to synthesize that. So which will be considered as the best method? In Williamson synthesis, sodium alkoxide that is being treated with the corresponding alkyl halide to give that ether. Here basically SN2 sort of mechanism occurs. So this one O minus, this one, this O minus, this will attack this beer and it will be liberated. So this is the best option, because any other option is, because this one cannot happen, because here minus is resonance stabilized. Here this Br will get partial double bond character. Here the product will be different, this will not get this one. So option C is the only answer. Next, question 4. Compare reactivity towards Grignard reagent of the following compounds. These are all three cyclic ethers. This is the basic thing, the ring strain. So order of stability of the ring, 6-membered ring is more stable, then 5-membered, then 4-membered, then 3-membered. This is the ring stability order. So most unstable ring reacts fastest to get stabilized. So the most unstable ring is the 3-membered stuff. So this one, then this one, and finally this is comparatively more stable. As it is most stable, so it has the least tendency to react with Grignard reagent. So A tops the list, then B, and lowest will be C. So option C is the correct answer. Next we'll move towards this problem. This compound, it has a special name. It's called paraldehyde or metaformaldehyde. Paraldehyde or metaformaldehyde. Sorry. Not. This is referred as trioxan. Trioxan or metaformaldehyde, not paraldehyde. Trioxan or metaformaldehyde. It basically is formed by trimerization of formaldehyde. 3 moles of formaldehyde are associated in a cyclic manner to form these trioxan or metaformaldehyde. So when it will be hydrolyzed in acidic condition, it will give back the formaldehyde once more. So 3 mole of formaldehyde will be formed. So option B is the correct answer. We'll move to question 6. Which of the following is most reactive towards hydrolysis? So here what we have to think the stability. When we will think the stability, this question 6. So what we have to understand that the when hydrolysis will happen, it will go via free radical formation, via carbocation formation. So where the most stable carbocation will be formed, that we have to focus on. So in option B will get the most stable carbocation. So here it will be most readily hydrolyzed. So B is the correct answer. Next, what is the product of the following reaction sequence? This is acidic hydrogen. When it reacts with CH3 methane is produced, and as a side product we'll get this one, C triple bond C MgBr, right? So this Mg del plus and C del minus, oxygen del minus, and this carbon del plus. So this will attack over here, the sigma bond will open and it will take up the MgBr. So what will be the fate? Will get this one, C triple bond C CH2 OMgBr. Then after H3O plus, the OMgBr will be hydrolyzed to OH. So option D is the correct answer. Next, we'll move to question 8. Among the following, which has the lowest pKa value? pKa value lowest, that means Ka highest, that means acidity highest. So which is the most acidic stuff? We have to consider the effect of the group other than OH is attached with the benzene ring. So here neither group is there except OH. Here NH2 is there, so nitrogen lone pair is donating. So plus R, here methyl will show plus I, and here NO2 will show minus I minus R. Due to this strong minus R and minus R, this OH bond becomes very weak. H plus readily dissociates, and as a result this compound D becomes most acidic. Its Ka value becomes the highest. It's minus log K, that means pK becomes the lowest. So option D is the correct answer. We'll move to question 9. So these 1 degree alkyl bromide is there. This is being treated with aqueous NaOH. This is a normal SN2 sort of reaction. So we'll get over here this one. CH2, CH2OH. Then it is being treated with 60% H2SO4. So when it is treated with 60% H2SO4, what will happen? So carbocation will be formed at first, CH2, CH2 plus. Then hydride shift will happen from here and carbocation will be formed over here. Then deprotonation will occur to form these alkene. So option C is the correct answer. Next question 10. Which of the following alkene on hydration using concentrated H2SO4 followed by boiling with water forms a tertiary alcohol? Where tertiary alcohol will be formed. So again, this is a reaction where we have to understand the mechanism, because with the help of the intermediate we can say where the tertiary carbocation can be formed. So where the position where tertiary carbocation is formed, obviously in that carbocation, in the last step, water will be attached to form that final product. So here at first, these carbocation will be produced. Then when water comes, it attacks here to form these 3-degree alcohol. So option B is the correct answer. Next question 11. This alkene is being treated with B2H6 H2O2 OH minus. This is a hydroboration reaction where hydration happens in anti-Markovnikov fashion. So what will be the product? A will be CH3, CH2, 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 1, 2, 3, 4, 5, 1, 2, 3, 4. This one, then it is being treated with copper at 573 Kelvin. It will be oxidizing. It is an oxidizing agent. This alcohol will be oxidized to form corresponding aldehyde. This CH2OH will be oxidized to CHO in presence of copper 573 Kelvin. So pentanal is the answer. Pentanal. NaL. Option C is the correct answer. Pentanal will be the answer. Next question 12. Identify A from the following reaction. 2,4,6 trinitrophenol. This is the final stuff we are getting over here. 2,4,6 trinitrophenol. Concentrated HNO. So B will be, of course, this 2,4,6 trinitrophenol. The picric acid is formed from phenol. Okay. And these high temperature 698 Kelvin in presence of steam and SiO2. Here in this reaction, phenol is formed from chlorobenzene. So A is obviously chlorobenzene. So option D is the correct answer. Next question 13. The following two compounds can be distinguished by. Two alcohols are given. this is aliphatic alcohol. This is also aliphatic alcohol. So red litmus paper, it is not perfect. Neutral FeCl3 aqueous solution, both will respond negative to these tests. Lucas reagent, this will be the answer, because this is a 1 degree alcohol, this is highly stable benzylic 2 degree. So here precipitate does not appear when it is treated with Lucas reagent. Here precipitate appears when it is treated with Lucas reagent. White precipitate, turbidity sort of things are formed in Lucas test. So these two alcohols can be distinguished by Lucas test. So option C is the correct answer, Lucas reagent. That's all for today. Signing off. See you tomorrow. Thanks for watching. Thanks for sharing good words about Talanta. Keep sharing, keep learning.